Welcome to Mindcast, your journey into the most fascinating and urgent topics shaping our world. I'm your host, Will, and today we're diving into a challenge that's literally consuming the future of artificial intelligence. It's a paradox born from success. The very breakthroughs in generative AI that excite us so much are now creating a profound and existential threat to its long-term improvement. Imagine a self-consuming dragon, powerful and intelligent, but inadvertently devouring the very essence it needs to survive. That's the core of what we're exploring today. How the proliferation of AI-generated content is creating a self-referential feedback loop, threatening the integrity of the data ecosystem these magnificent models depend on. This isn't a hypothetical risk. It's happening right now, with observable, real-world consequences. For years, the incredible ascent of large language models has been built on a powerful yet surprisingly simple idea. Give them more high-quality data and more computational power, and they'll become more capable. This scaling law has truly propelled generative AI from a specialized research area into a transformative global technology, astounding us with what it can do. But here's the twist. The very success of this technology has inadvertently unleashed a profound challenge, one that threatens its long-term, sustainable improvement. Suddenly, the central mechanism of this issue becomes clear. Models like OpenAI's ChatGPT and Google's Gemini are now generating immense quantities of fluent, coherent, and often incredibly convincing text, images, and code. This synthetic content, much like a rapidly flowing tide, is quickly saturating the public internet, which has historically been the primary data source for training the next generation of models. We're seeing this play out in real time. Recent reports confirm that conversations with ChatGPT are showing up in web search results, and a large-scale study from April 2025 found a staggering 74.2% of newly created web pages contained some form of AI-generated content.
This isn't just passive content pollution either. It's being actively accelerated by the operational design of new AI features. Think about Google's AI overviews, which place a generative summary right at the top of search results, or the very architecture of models like Gemini, which explicitly use the live web for grounding and information retrieval. This creates a direct, high-speed ingestion pipeline for potentially polluted data, establishing a closed loop where AI generates content, that content is published, and then retrieved and used by another AI as a source of truth. This dynamic marks a critical inflection point. For years, the bottleneck was always data scarcity, the immense difficulty and expense of acquiring and processing petabytes of text and code. Generative AI solved the quantity problem, enabling virtually limitless data creation. But in doing so, it created an even more insidious problem: the challenge of data authenticity. How can we verify that any given piece of data is a genuine reflection of original human knowledge and not just a distorted second-generation echo of a previous model's output? It's a complete paradigm shift, and it's a fascinating, if daunting, challenge for the future of AI. Now, this isn't just about data quality dipping. It's a specific degenerative phenomenon known as model collapse. The most vivid analogy for this is Habsburg AI. Think of the historical Habsburg dynasty, which suffered from severe genetic degradation due to generations of inbreeding. Similarly, an AI ecosystem that recursively feeds on its own outputs, a form of informational inbreeding, risks becoming an inbred mutant. It starts producing increasingly homogeneous, repetitive, and ultimately useless content. This process, also called model autophagy disorder, describes how a model trained on synthetic data gradually loses its diversity and grasp of the real world. This decay isn't sudden, but unfolds in two distinct stages. First, early model collapse, where the model loses information about the tails of the true data distribution, those rare events and nuanced details crucial for a rich understanding. Performance on common tasks might seem stable, masking this loss of diversity. Then comes late model collapse, where outputs become catastrophically homogeneous, repetitive, and the model loses its ability to produce coherent, informative content, rendering it useless. This isn't a bug to patch. It's an emergent, fundamental property of learning in a closed information loop. It implies that sustained AI intelligence, under our current paradigm, depends on a continuous connection to authentic, low-entropy information, the real world.
But this theoretical risk of model collapse isn't just academic speculation. It's actively unfolding and accelerating right now, driven by how AI is becoming deeply embedded in the web. The digital information ecosystem is rapidly becoming saturated with AI-generated content, and major search engines are creating a super-fast feedback loop, funneling this synthetic content straight back into the training pipelines of future models. The scale of this AI pollution is truly staggering. We're seeing the web flooded with low-cost, mass-produced synthetic content, everything from derivative ebooks and fake travel guides to AI-generated videos. There are even news websites almost entirely generated by AI, surfacing in search results and monetized. It's a real tragedy of the commons for our global information ecosystem, where the ease of generating low-quality content degrades the shared resource for everyone. At the heart of this dynamic is the modern search engine, which is evolving from a passive index to an active information synthesizer. Take Google's AI Overviews feature, which uses the Gemini model to generate a summary at the top of many search results. This is a prime example of a mechanism accelerating the data poisoning feedback loop. A landmark study from the Pew Research Center found that users seeing an AI overview were significantly less likely to click on traditional search result links. They barely ever clicked the source links in the summary, and were more likely to end their browsing session entirely. This means users consume the AI summary, are satisfied, and don't explore further. This devalues original human content, shifting economic incentives toward low-cost AI generation, further polluting the web and feeding future LLMs an even more homogenized diet.
So, with all this talk of data poisoning and model collapse, it begs the question, is all AI-generated data inherently detrimental? Is synthetic data always poison for our models? Well, not necessarily. Let's deconstruct that shortcut myth, because the answer lies in how it's used. The remarkable performance of models from the DeepSeek family, which often rival and even surpass some of the biggest names, offers a compelling case study. It's often mistakenly thought they just took a shortcut by training on outputs from models like ChatGPT. But that's not just factually wrong, it's legally impossible due to terms of service. The true story of DeepSeek's success is a highly methodical, multi-stage training architecture that pioneers the strategic use of self-generated synthetic data for very targeted skill development. Their process is the exact opposite of a simple shortcut. It starts with a rock-solid foundation, massive, high-quality pre-training on trillions of real-world, human-generated tokens. This is the non-negotiable bedrock of language and facts. Then comes the innovation. For reasoning tasks like math or coding, they don't use subjective human feedback. Instead, they train a teacher model using rule-based reinforcement learning, where the reward is simply whether the answer is objectively correct, like a math problem passing a test. This results in a model with incredible reasoning, even if its outputs are a bit unpolished. Then, that powerful but raw teacher model is used to generate a massive, high-quality synthetic dataset of reasoning problems and step-by-step solutions. This self-generated textbook is then used to fine-tune a base model, not to teach it new facts, but to distill those structured reasoning patterns and, crucially, to teach it how to present that reasoning in a consistent, readable, and human-friendly format. It's a precision tool for sharpening specific, verifiable skills, not a substitute for reality. Now, these techniques, pioneered by labs like DeepSeek, are part of a larger industry shift, truly embracing synthetic data, but with purpose. This isn't just about cutting corners, it's about engineering data to overcome the three massive bottlenecks of traditional AI development: the cost, the sheer scale, and the ever-present privacy constraints of relying solely on human-generated and annotated data. It's a shift from data as a finite resource to be found to data as a malleable asset that can be strategically engineered. Two core methodologies are driving this exciting shift. First, we have knowledge distillation. Imagine a huge, brilliant teacher model that's learned tons from massive data sets. Knowledge distillation is about taking that teacher's deep, nuanced understanding, its dark knowledge, and efficiently transferring it to a smaller, more nimble student model. The student learns not just the final answers, but the subtle patterns and probabilities the teacher figured out, inheriting its intelligence without having to relearn from scratch.
Then there's self-instruction. This is truly mind-blowing. It allows a model to actually improve its own capabilities autonomously. It starts with a small, curated set of human-designed instructions. The model then uses these as examples to generate a huge number of new, diverse instructions for itself, complete with input and output pairs. After rigorous filtering to ensure quality, this self-generated data is used to fine-tune the original model. The result? A dramatic improvement in the model's ability to follow complex, unseen instructions, essentially turning the AI into a data-generating engine for its own evolution. These approaches are helping to unlock new levels of efficiency and capability in AI development.
Now, while these techniques are undeniably powerful on a technical level, the strategic use of synthetic data opens up a profound ethical minefield. Beyond just the risk of a general model collapse, we're talking about systematically distorting a model's outputs in ways that can cause real-world harm. One primary danger is the amplification of societal biases. Think about it. LLMs are trained on the vast, often biased internet. When a teacher LLM then generates synthetic data, it's essentially creating a data set reflecting its own skewed worldview. And here's the kicker. A student model trained on this biased synthetic data doesn't just replicate the biases, it often amplifies them, leading to progressively more unfair or discriminatory outputs. Then there's the risk of pattern overfitting. Real-world data is wonderfully messy and diverse, but synthetic data tends to be more uniform. If a model extensively trains on this uniformity, it might learn the stylistic quirks of the generator rather than the deeper underlying concepts, leading to a significant degradation in its ability to generalize to new, unseen real-world data. And on a broader, ecosystem-wide level, imagine AIs predominantly trained on the outputs of other AIs. This self-referential loop poses a threat to informational and creative diversity. We could end up with a digital landscape where content converges on a bland, generic mean, perfectly fluent and grammatically correct, but lacking the true spark of genuine innovation and the delightful surprise that defines human creativity. It's a serious ethical tightrope we're walking.
So, how are the major players in the AI space? The big tech giants like OpenAI, Google, Meta, and Anthropic responding to these profound threats of data poisoning and potential model collapse? Well, they're not just sitting back. They are actively constructing what I'd like to think of as a multi-layered fortress to protect the integrity of their models and, let's be honest, to preserve their immense competitive advantage. This defense strategy is truly comprehensive. It starts with formidable legal barriers, then moves into highly sophisticated proprietary data curation pipelines, and finally embraces emerging technological countermeasures like advanced AI content detection and digital watermarking. First, the legal wall. You might wonder if a developer could just train a new model on the outputs of, say, ChatGPT or Gemini. The answer is a resounding no. And it's enforced by explicit prohibitions in the terms of service of every major provider. These aren't hidden clauses. They are direct, unambiguous rules designed to prevent competitors from freely benefiting from their massive investments. It's a powerful one-way valve for knowledge, with information flowing into their systems, but legally blocked from flowing out to train rival models.
Beyond the legal aspect, we see incredible innovation in what I call data refineries. As the quality of raw web data declines due to AI pollution, the ability to effectively clean, filter, and deduplicate massive datasets becomes absolutely crucial. Companies with the best data pipelines will build better models, even from the same increasingly polluted source. This includes advanced filtering for hate speech, spam, and personal information, as well as increasingly smart techniques like superfiltering, where a smaller AI helps identify high-quality training data for a larger one. And finally, there are technological countermeasures. We're talking about actively researching and deploying tools to detect AI-generated text that might slip through filters, and even more proactively, to watermark their own outputs. Google has already rolled out SynthID text for Gemini, embedding an invisible signal into the text to mark its AI origin. These steps aim to make the data ecosystem more transparent, even as it becomes more complex.
So, with all these challenges and defenses in mind, what's the path forward for sustainable LLM development? The most robust and effective strategy is what we call the hybrid data imperative. This isn't about choosing between human-generated or AI-generated data. It's about intelligently combining their strengths. High-quality, meticulously cleaned human-generated data must remain the absolute bedrock of any training corpus. This is our essential ground truth, the irreplaceable source of low-entropy information that grounds models in reality and prevents them from drifting into self-referential loops. It's how they genuinely understand language, culture, and common sense. Synthetic data, on the other hand, should be deployed as a strategic precision tool for targeted improvements. Think of it for specialized skill fine-tuning in areas like mathematics or coding, where an external checker can validate correctness, or for deliberately augmenting data to fill gaps and enhance fairness. It's also brilliant for knowledge distillation, compressing the capabilities of a large teacher model into a smaller, more efficient student.
Implementing this responsibly requires a rigorous governance framework built on 3 pillars: legal compliance, ensuring thorough audits of any external data sources; robust technical safeguards like continuous monitoring for early signs of model collapse and maintaining golden human curated validation sets; and crucial ethical oversight, including actively auditing teacher models for bias and incorporating human-in-the-loop review for sensitive applications.
As we look to the future, it's clear that the path to truly intelligent and sustainable AI models doesn't lie in a complete detachment from reality. The specter of model collapse shows us that a system learning only from its own imperfect copies is destined to degrade. Instead, the most advanced and enduring AI will be the one that cultivates a sophisticated, continuous, and symbiotic relationship with the real world. It will use its powerful generative capabilities not to replace human reality, but to better understand, curate, filter, and learn from it. The greatest challenge, and indeed the greatest opportunity for AI, isn't escaping its dependency on authentic human data, but in managing that dependency with increasing intelligence, responsibility, and wisdom.